80, 89% of the CIOs prioritize, say the technology leaders, that listening agentic AI is a strategic initiative, right? So again, easy to say, hard to do, but 89% of them are expecting us to build agents and be able to manage them, right? So the good news is, or the bad news is that in the next year, we expect to see about 40% of these projects canceled. And the reason we're seeing that is for a lot of things we talk about in like in our demystifying series and the webinar we had last week, is that all these applications are kind of stuck in this prototype zombie land, or just in limbo, right? Because what we're doing is we're building these apps and we don't understand how to evaluate them. So the interesting thing is that to build the chatbot, you can do it in a couple of hours, right? But the problem is that going to be good enough to take into production? And what we've seen is, no, that's not true. And the problem is that we get everybody in the organization excited about these prototypes or these pilot systems. They look great. We curate some data, ask all the right questions, seem to be getting all the right answers, and we get everybody excited. And what's happening is that we really need to prepare our organization better for what's going to happen, right? We need to be able to evaluate the system and get it into production, right? So what I want to talk about is focusing on how do we instrument. And so it's funny that as I'm putting this together, I'm thinking traditional AI evaluation is basically this one turn, right? Now, I took two extreme examples, right? These are screenshots out of a product I like to use, which is Phoenix Arise. And on the left-hand side, so traditional, again, this is just a few months ago that what's happening is that whether it's like if you had a RAG system, there'd be a couple of other steps in here. But what's happening is that evaluating on just a RAG system or a chatbot was, I'm going to say, as simple as creating a gold data set, setting up some in LLM as a judge, and trying to do a validation off of a response. And then maybe you had another evaluator that was checking the data that was coming in, right? So, and let's call that context, right? Whether it's coming in from a semantic search from for a RAG system out of a vector database, or if you're pulling data out of a agentic system, right? Like maybe your agent is pulling information out of a vector store, right? Which could happen too. And so those kind of evaluations are pretty kind of isolated, one or two type of things. What we're seeing more and more with this proliferation of inability to speak, this proliferation of agentic AI is now we're looking at multi-step reasoning. We have memory we have to contend with, and then it has a lot of autonomy. So we can't use the old tools. We can use the old tools, we can't use the same behavior. If you look to the right, that example is a very basic just agent that has two tools. It's got a policy lookup and a FAQ lookup, right? So if I go in and I ask a question and it's policy related, it's going to use the policy tool. If it's FAQ related, the FAQ tool, right? Pretty obvious. If it's kind of combined, it'll call both the tools. It knows it needs a tool. And so it's going through all of these steps, right? And all these steps need to be logged, right? So again, this is basic and it's just querying. Imagine if these tools are actually updating a database and if we have multiple, right? So we want to talk about that. So what used to happen, right? We used to have back in the day, and they still exist. I'm going to say CICS just once because I think it's fun. But we had our OLTP systems, right? And so you had transactions, but it was linear. And what would happen if it failed is you'd have a simple rollback. You would simply roll back the transaction, right? So, information got put into the database, you have rollback defined, and you would pull it out, right? No problem, no harm, no foul. When we look at multi-agent systems, they're asynchronous and they're contextual and they're adaptive. right? So you really can't control it the same way you did in a linear. And I'll talk about rollback a little bit more, or how we, if we have a problem in an agentic system, what is it that we need to do, right? So basically what happens in our traditional, again, it's fun to call it traditional evaluation, is that we had this illusion of accuracy, right? So we came out with a final answer, and we looked at response latency, we looked at token usage, made sure it was efficient, and that's what we were kind of tuning and tweaking in our model. If you look at the bottom, the blue bar, we talk about like a customer service refund bot, right? So correctly refunds $50, and that's accurate. That's what it should have done. But what happened is, part of the agentic system, it inadvertently corrupted profile data in a database transaction. So this could have been something as simple as I'm like a lot of snowbirds in Florida, right? So maybe I have a refund, and I tell them to direct the refund to my address in Florida. Well, part of the agentic system sees a new address and it updates it and makes it my home address, right? That's a data quality error. That's not my home address. It's a vacation property, right? So now all my mail's going to my vacation property. I go back home and all my mail's here, right? All my information. So that should be considered a failure, right? And traditional evaluation is going to mark that as a success because I got my refund back. And so basically what I'm pointing out is that in these multi-step systems, you could have reasoning errors, and it could be tool misuse, like what if it calls the wrong tool, governance violations, and then behavioral drift over time, right? So these are the kind of things that we need to be thinking about as we go forward. So what's happened is that a lot of large organizations are starting to converge on this 8-step evaluation framework, right? And so it's in general, it breaks into categories like synthetic scenarios, and I'll talk about each of these in more detail, but synthetic scenarios, modular evaluation, right? We have a lot of pieces and parts, trace logging, and then automated testing. If we don't get automation, and if we don't bury this inside of our full development pipeline, you're never going to be able to keep up, right? So you got to be thinking automation first, evaluation first. So in each of these slides, what I'm going to do is I'm going to describe it, and then off to the right, just some general kind of flow. And I'm not obviously going to read through all this. I may talk about some key steps. But what I want you thinking about is that if you come back to the video, you can pause this and take a look at the type of workflow to kind of give it a little bit more oomph, right? We don't have time to get into all the technical details, but I want to do two things. One is I want to help you understand how complicated it is, and then figure out how do we break it down to make it less complicated, right? So when we talk about synthetic scenarios, what we want to be able to do is make sure we're generating adversarial tests from the beginning. We want edge cases, we want to stress test production, we want prompt injection, multi-agent coordination failures. So for example, in that very simple example I talked about earlier, we want to replicate the fact that I was in the middle of doing a refund, and maybe the user decided they didn't want a refund and they tried to cancel it. Right, so maybe the cancel goes through, but the refund still happens, right? So we want to create those scenarios to see how we can test them. What happens if the resources get exhausted and things just fail? Or we test in ethical boundaries, right? So what we want to be able to do is we want to simulate the upstream data, returning partial or stale data, and then see how the system responds. So for example, let's say the test input, I've got customer ID, person's name's Alex, and the email's null. Well, while we're testing, is the email important? If we're using email as the user ID and for authentication, it's critical, right? So we want to make sure that we have tests in place to say, look, the expected behavior is I don't have Alex's email on file. I can't complete the refund without confirmation. Would you like me to? And then it does whatever it does, right? Or it calls an agent, agent gets on the phone, and they talk to Alex, get things straightened out, right? And so what you don't want to have happen is you don't want to have the agent execute and then update with blank or missing information, right? So in this case, I'm still going through puberty, so my voice keeps cracking. But in this case, some remediation could be, to add pre-action checks in the policy layer, make sure you require email true, and then have these things, right? Not everything needs to be solved with AI. There's some validation that you can take care of in the front end. So anyhow, so you want to be creating these synthetic scenarios. The next thing is that comprehensive logging, and this is just kind of a touch point for logging if you look off to the right. But the nice thing is that the evaluation tools like Phoenix Arise, Langsmith, Snorkel, the prompt layer, all these, they all use a open source, open telemetry. So it's a standard, if you use Datadog or any of those logging frameworks or reporting frameworks for your backend systems today, they're using open telemetry. So when we create logging for our GenAI systems, we're going to use that same technology so that we can, log them to the same database and have all that information logged. They're very fast, pretty low overhead, things like that we want to think about. But we want to make sure that we have structured trace spans for each action, right? So we may not have the concept of a transaction anymore, but we do have the concept of workflow. So we may want to have a span and that takes through now and the start of the span so that you can see where things start, the way they went through and where they ended, right? So if you capture all this with the reasoning chain, which all the models and things push out, tool invocations, and then any error states or recovery attempts, right? So we want to make sure all this is logged for a bunch of different reasons. One is we want to be able to trace in a development environment. We want to be able to see these logs and make sure that the flow is going the way we want. When we get into production, as we put this in, there are a lot of things that it can be used for. One is compliance. We can run other jobs that are looking through the log and making sure that we're looking at error states and things like that. We can also do some analysis on which agents are getting called. We'll talk a minute in some metrics. How do we tell if it's efficient or not? And we can glean a lot of that information from the log. So automated evaluation at scale. So we can deploy an agent as a judge, right? Or multiple agents as a judge. And what they do is they evaluate other agents' output, right? So these metrics like tool utilization efficiency. And so off to the right, I just have a simple example, right? So let's say a retrieval agent has 3 tools, right? Search documents, summarize text, and generate answer. So if we're logging all this, we'll see that it went out and searched the documents and it got a success, right? We have some context scoring in the back end, summarize some text. Again, we passed. And then for some reason, we went out and searched the agent went out and searched documents again. And then we generate an answer and we deem that answer to be successful, right? So just simply useful tool calls 3, total tool calls 4. And so then, from the LLM as a judge for the answer, we got an evaluation score of 90%. So we're pretty happy with that. But when we look at it overall, the TUE, we're not very efficient, right? So, and in this case, it was one simple thing. We're doing a redundant search documents, right? Which can kill us, right? The search document, probably the biggest, well, it depends, but can kill us, right? We don't want extra things happening. And when we give it to the agent, it's going to do what it's going to do, right? So we want to be able to track these things and understand them, right?
Hey, Marty, before you go on, we have a couple questions.
Oh, no. Hey, just
Yeah.
give me the easy ones. Skip over the hard ones.
Perfect. So
All right.
when we're thinking about EDD, what would you say, where would you say this is equivalent to the traditional development processes we probably already use?
Yeah, so I mean, there are a couple things. EDD in general, if you just look at it, it's going to feel a lot like behavior-driven development. It feels like it's on top of the system, but it can be built into the CI/CD pipeline, and you can use it like TDD-ish, right? Some of the things that we can do is when you're doing evaluation, what you have to do is integrate it to the whole system. So you can do some TDD-like things using the EDD concepts through the pipeline to like validate specific agents, right? So you would do it just to evaluate an agent. Maybe you're not looking at the full workflow, but it's very much like the test-driven development. So behavior-driven development, same concept. But the thing that worries me with that is that you know, those type of technologies got pushed down. They got misinterpreted, right? Like if you ever talk to I think it was Beck, he always looked at TDD like a way to design an application, right? And then we kind of relegated it to this back end testing, right? Which isn't its intent. And so I want to make sure that EDD doesn't become the same thing. Actually, what I think we're going to see with agents is that EDD is going to be that ability that lets our agents kind of correct themselves. So if we want a fully autonomous system, we're going to have to marry the two together, and the system is going to be built around making decisions and evaluating the decision and making sure that everything's kept in line.
Okay. And
All right.
one more, for agent as a judge systems, what do the evaluation metrics actually measure? And what would success look like?
Yeah, so man, I'm going to give you a consulting answer. It kind of depends, but what happens is that when we do any type of LLM as a judge, it's driven by the prompt, right? So just like any large language model, right? We're going to give it a system prompt and we're going to tell it to do something. So what we're typically going to do with LLM as a judge is there's going to be a prompt that says, evaluate this for X, right? So for conciseness, for whatever. Now, what typically will happen is we'll score that, and then we're going to go through that list of scores for, like, let's say it bangs against the agent like 9 times. We're going to take that average and use that as an accuracy measure, right? So the other things that we can do is use LLM as a judge to also tell it the context. So if I have a RAG system, the context that's coming in that I retrieved to validate against that, right? So we're gonna have some accuracy scores. Don't use precision much. That's more in the ML realm. But with the LLM as a judge, we're gonna define how we're measuring that based on the system prompt that we're using. Cool.
So you'd see it not only in the development process, but in the deployment process, smoke tests, post.
Oh, yeah, absolutely. Yeah, absolutely. Right. So one of the things that I propose is that you put it into the CI/CD pipeline, and the best way to do that is using like Gherkin or some sort of tagging system. So that if I'm a developer, obviously I want to be able to check things in, and I don't want to take 20 minutes every time I check something in, right? So what you're going to want to do is, if I'm working on a specific part of the system, let's say, agent A, I want to have tags that pull agent A testing only, right? So I'm going to do agent A, and so I'm going to, every time I check in, I'm going to do some validation again, agent A. At night, what I want to do is I want to run a fuller breadth of tests, maybe a larger data set, maybe 1,000, 10,000 rows, something like that. And I want to run that overnight. And then what's going to happen is then what we'll do in our stand-ups in the morning is they'll shift slightly, and it'll be, if you're building GenAI apps, what you're going to do in the stand-up is you're going to look at the evaluations and say, hey, did we have any issues with the evaluations? Are scores low? Are they dipping? If they are, what do we need to go do about it? Do we need to tweak a prompt? Do we need to make a change? And then as you move towards production, what you're going to want to do two things. One is you're going to want to put some sort of, I'm going to call it random, but obviously it's not completely random, but you're going to have some variable every once in a while. You want to run it against a live transaction, right? Now you got to be careful, because if you do too much of that, latency and all that stuff will skyrocket. The other thing is that if you have a full breadth of observability of logging, then you can let the production systems run and log, and then you would run the evaluations against the log data, right? But you want to make sure that that it's constant and in the system. Cool.
Cool. No more questions from the crowd yet.
All right. Cool. All right. All right. Then component end-to-end testing, right? So we want everything, right? So tool usage, memory retrieval, planning logic. What are the emergent system behaviors, and can we catch these failures that unit tests miss, right? And so this example here is that I have agent A that's payment, agent B is taking orders, and they both have clean unit tests. And then what happens is that the contract for A may tell it that it can go ahead and retry a payment. And the contract for B says, hey, after 3 failures, you're done, right? So if I do an end-to-end test and I'm running simultaneous events, it could be that A is retrying and then B comes in and cancels. As A is trying to retry, A's retry is successful, and after the retry is successful, B cancels, where the intent was for B to cancel before the retry hit, right? And so we'll see those when we do end-to-end and component testing, right? So we don't want the payment to succeed after the cancel. I think I said it backwards, but that's what we want, right? And so, to fix this, we may have to introduce a coordination broker, or maybe if they're highly important, we serialize it to make it look and kind of feel like our old OLTP systems, right? We did the same type of things, right? We had memory brokers and things like that in those systems, right? So we have to think about those kind of things. Now, LLM is a judge with human oversight, right? So this is really where we're running our evaluations, and I'm using a screenshot out of Phoenix Arise again, and you can see down here in the bottom what it was doing again. Very, very simple, but it's pretty colorful, so I liked it. But if you look down to the lower right, you'll see a purple indicator. I think it's purple, and then it says evaluate all responses, and it's got a 1, right? So what this was ran some questions and said, hey, the prompt was respond to me in a poem or in a rhyme. And then I went in and evaluated it and said, yeah, this worked, this didn't, this work, right? So this is an example of we do something, then we have a human go in and validate it. And then what would happen is that this data set would then be used as part of our evaluation process, right? So now you have, when you use an LLM as the judge, it's got the input, right? It's got the query, it's got the prompt, it's got the output, and then it's got how it was scored on the evaluation. A lot of times on the evaluations too, is you can give it a description as to why you thought it scored well. And the models and the judges, actually you want to move it into the model. The model can then use this so that it's generating better responses for you. And so the human in the loop part is not going away anytime soon. And I would suggest you don't try to get rid of it anytime soon, right? Definitely needs to be in all the way up through staging. So prediction powered inference. So basically what we want to do is we want to leverage historical evaluation data to help predict likely failures, right? So what may happen is if you think about this logging, so I'm going through and, the first scenario, I do a refund, the grounding score is good, tone matches the tone of our environment. Was it helpful? And it wasn't a failure. So finance, right? And then the domain. So we have these, the history of these transactions. So then what you can do is you can now feed new unlabeled scenarios in, like last night's run, and use a lightweight classifier like XGBoost or something like that, and do some logistical regression against all of the responses. And then I would love to tell you exactly what this formula is, but I know the formula works, right? So you can use this inference estimator and then build this into your scoring, right? So now what's happening is if you then take this and then feed this back into your evaluation system, the evaluations get better, right? Or to be more precise, it starts to evaluate more the things that you think are going to fail, right? And so what happens is you get more focus on the expected failures, which is a good thing, right? So now you're going to see those in your overnight runs or during your check-ins. Multi-stage validation. This is the one that gets kind of complicated, right? So what you want to do is so you're going to run through and you're going to build a stage gates of validation. So if you go through step one and it doesn't reach the scores that you want, right? So you're going to basically at the end of that go, I suggest we go to gate one. So you go through gate one and your confidence score, you want your confidence score to be over 80% and it's under. So if it's under 80%, you're going to trigger gate two. It's going to go through gate two. If it passes gate two, you're done. If not, it may send you to gate three, right? So you may have these the kind of tiered processes to go through, but especially when you're one of the things is kind of like when you think about what we did to ourselves with microservices, right? We realized, hey, if we make these big monoliths, then they're going to be harder to maintain, things like that, right? So agentic systems are the same thing, right? You're going to create smaller agents that are very good, but then you're going to have another agent over here. They're going to talk to each other either through some memory bus or some messaging system or whatever. And so now you want to make sure that, hey, this may have passed and this may have passed, but then do I need another stage gate to make sure they both pass, right? So I have to think about things like that. And, we want to build regulatory requirements and ethical guidelines into the layer from the beginning, right? Just had this conversation with a client. Some of this can be handled with logging, right? So you can go through and, as long as you're logging it, they can go back and audit the logs and make sure things are being compliant. But, PII, in our training, we talk about this, right? Put guardrails in at the beginning so that you can mask PII so it never even enters the system, and then maybe check it on the back end, right? Regulatory SOX, GDPR. Ethical bias. I think ethical bias is one of the hardest to manage. One of the things that I've seen teams do is they have a diverse set of people, and they may not all be in development, but maybe QA and product management. But you want a diverse set of people looking at tone and bias because, we don't know, right? Like a friend of mine, when ChatGPT first came out, I was like, this is the coolest thing ever. And I'm posting LinkedIn all the time. And a friend of mine who like very sharp, right? She calls me up and she goes, hey, you might want to take it down a notch with ChatGPT. And I'm like, why is that? And she goes, it's really biased. Like if I ask it any questions about like a surgeon or money, it just assumes I'm talking about a man. And I'm like, and so I was thinking, I better choose my next words very carefully, right? And but she's right? It does things like that. So we have to make sure that we're building those policies in, and we have to do it from the beginning, right? So what do we do if something goes wrong? Because it's going to happen, right? In our OLTP system, we had this, if it failed, we did a rollback, right? I'm saying simple now. Somebody had to solve that problem. They solved it, and we all kind of know how to do it. So in agentic systems, what a rollback means is really we have to replan, we have to compensate, and then we have to reconcile anything that got messed up, right? So if you think about this, it's almost like if you want to have an autonomous system, it's got to learn. It's got to learn, it's got to teach itself, and it's got to correct itself the whole time it's working, right? So the evaluations and the evaluation set needs to be thought of as a recovery, an enablement and recovery system, right? So it's not a QA process. It needs to be embedded so that when you build these really cool applications, they actually learn and do the real things, right? So what happens is the evaluation replaces the rollback as a control loop. So this is me playing with Sora, right? So this robot learned, right? Poured the first cup of coffee all over the counter, and now it's all happy because it figured out how to pour it into a cup, right? So instead of reverting transactions, what we want to do is have the autonomous systems learn and correct their behavior. And so the evaluation is going to drive that adaptive correction rather than reversing things. Right? So when we talk about governance, we definitely want to come in with a zero trust architecture. Every client that I'm working with that does this, that's almost first words out of their mouth, right? Want to make sure that the agents and everything is being authenticated. Access scope, we want to tighten it down and only give it privileges when it needs them. Want to make sure that our policies are being enforced. You know, this gets interesting because like our data governance policies are good, right? And most organizations have them. A lot of organizations have them as a document. And then we have levels of, have they shared that document? Does everybody understand that document? Is everybody following the document? And we want to move that more towards how can we automate that? And I know there are systems that do it. I know IBM has ways to do it. Azure's got some good architecture for doing things like that. And then audit logging and detection. We have to be tracking all of this stuff, right? Even the first couple of chatbots that I built, I was doing it and I didn't know things like I was using LangChain. And Langsmith wasn't really out yet. There wasn't a lot of talk about evaluations, but I knew there had to be a way to trace it. But what I was doing was I was doing prints. Like I would get a response from the LLM and I would just dump everything to the console, and it was painful, right? And as these tools started to become available, and I was able to use Langsmith and eventually Phoenix Arise, when you see that flow, you can almost assume, even without looking at the data in the prompt, you can almost see where your problem is, right? When you look at it. So this logging and the detection, and then I think there are going to be more and more tools if they're not already out there. Like I know all the tools, but from a logging perspective, there are going to be tools that help you analyze the log, right? I mean, it's AI, for God's sake, we should be able to do stuff like that. So,
Hey, Marty, Marty,
yeah.
could you go back a slide? We did get an interesting question. Is there a kill switch in the process if an agent crosses a boundary, even during eval?
You'd have to build it in, yeah, but absolutely, right. But you would have to build that kill switch in. There's no reason you can't, if an eval fails, to shut the agent down, right?
Okay.
But again, you'd have to build that in. Otherwise, another process is going to come in and start using that agent.
And then there was another question about the amount of evaluation that we're doing in the pipeline, in the inference pipeline. Does that have an impact on latency and response times? And how do you balance that, find the right amount of evaluation in your process?
Yeah, that's absolutely true, Brian. I mean, it's going to happen. So you do have to plan for it, right? So there are a couple things that you can do. One is from the development standpoint, you think about the developers going through a CI/CD pipeline. If your check-ins are 10 minutes long, nobody's going to check in until the end of the day, and we don't want that, right? So how do we make sure that that CI/CD pipeline is still tight, right? Same kind of issue. It's a latency issue. So what I've used in a couple different clients is that I've used Gherkin and give when-then criteria to describe how I want to validate certain agents. And then I use a tagging system that allows me to pick and choose while I'm doing my run, right? When you run PyTest or Behave or SpecFlow, you can give it a parameter that tells it what tags you want to run. So if I'm changing like agent A, I'm going to use whatever tag that corresponds to making me test agent A. And I'm going to do that. I'm going to get that working. And then at night, what should be happening is that I have a tag that says, nightly QA or something like that. So then it'll maybe that runs through 10,000 scenarios across the thing. Then when and hopefully we catch everything there. But we still need something in production, right? We want to, as we move into production, I think if we want zero latency, the best thing to do is to, if you're logging everything, typically in the log, you have the prompt, what was called, you have the response, you have whatever context is being fed in. And so you could take that information and analyze that like offline, like outside the agent, right? It does some logging and you have an eval running asynchronously from your system, right? So that's a way to do it. And again, if you use some sort of tagging, I'm not sure I would send my, Gherkin all the way into production, but you may want a couple of like litmus tests, like every once in a while, like every 100,000 transactions, something kicks, right? But yeah, latency in the evaluation process is a concern, and we have to be careful about it. Okay.
Great.
All right, cool. All right. So it's kind of what I was just talking about, right? So in your sandbox environment, you want to be able to obviously, this is no different than any other kind of development flow, right? On a sandbox, we need some sort of controlled environment that looks pretty much like production, so that we can monitor everything. This is a good place to have human in the loop, right? Because it's a system that we think we're going to deploy. You could possibly do the controlled deployment to a small subset of people. Like maybe you release it to 10% of your clients and you still have a human in the loop doing some validation on the back end, right? And so it'd be a good way to get the system in people's hands without just letting it run rampant, right? And then as you get into full deployment, you want to get to the point where you can give it full autonomy, but I wouldn't do this until your governance maturity has been proven, right? You want to be pretty tight. And then I mentioned here, you want to be able to implement kill switches and rollback mechanisms for any kind of responses and handle emergent issues, right? Because we all know that, it happens, right? Somebody makes a small change to a system prompt, doesn't seem like a big deal. It tests okay and it gets into production, and all of a sudden things break and nobody can tell how or why. And it's not an easy thing to find, right? It's difficult. So again, your best bet there is making sure you have logging and that you start treating like system prompts and things like that need to be treated like production code, right? So it needs to be treated like production code. So it should be versioned and you should be able to roll it back. So basically a key principle here is autonomy is earned, right? You can't just say, well, here's my agent, knock yourself out, right? And we have to talk about what these stages look like and how do we de-escalate, how do we mitigate issues, right? We have a lot of techniques that we've used in production development that we're going to have to move and morph. And a lot of companies are already doing this, but we don't necessarily have to reinvent the wheel, but we do have to rethink how we do this if we have autonomous things just happening in the background. So, what are the cool kids doing, right? Salesforce, with Agentforce basically has kind of some of the fastest ROI with built-in tools, right? And so one of the reasons for that is not only are you living in their ecosystem, but they have an evaluation framework built around it, right? So when you go in and code it, it's all built in together. So the likelihood of you breaking something is slimmer because it's already kind of put in place. Same thing with Microsoft. Basically they're kind of leading in the HIPAA, SOC 2, GDPR space with compliance. Watson X is, man, I saw a cool demo with Watson and some medical, where it's walking a practitioner through, like a surgeon, through analyzing braid scans and then making sure it's keeping, and it's so natural the way it does. It keeps the surgeon in the loop by just asking it questions and making it improve things before it moves on, and has areas where it gives you all the context as to where it found information, right? So it's citing examples, and the system's pretty tight and it just looks cool. Right? And then Google with Vertex AI provides pretty sophisticated tools, specialized agents, and advanced evaluation. But again, it's all built in together. So it's hard to think of it piecemeal. So then for those of you who know me at all, know I'm a huge fan of LangChain, right? So, what does that mean, right? So we have this dilemma with DIY, right? Is that we get a lot of flexibility, but it lets us, we have a lot of flexibility, but it lets us ignore the evaluation side, right? So in reality, what's happening is these DIY projects are getting about 60% done, and then not moving forward. Months to production. The average time to POC to build these custom apps is like 18, 19 months. And then cost overruns are huge. And so why is this happening, right? It's basically we're missing evaluation frameworks from the start. Typically what happens is if people are in that roll your own mentality, they're also in the mentality of roll your own evaluation. And if you treat evaluations like a QA, like we treated the test-driven development, things like that, it's going to be a failure, right? And so, we need to make sure that that's part of the system that we're building. And then just evaluation-driven development, basically the most successful deployments are when this is built in and it's not treated like QA. Right? It's got to be treated like a core strategy, and it needs to be part of the architecture. And so what am I seeing for top adopters? Is it for AI or for evaluation? I'm going to answer both because I want to. So I think the biggest is, I'm going to start from where I've been focused, right? I think the biggest hurdle right now is that people don't fully understand how to evaluate these systems, right? They've seen a lot of YouTube videos on how to create these applications. They're not hard to build, right? I can build, especially if I have access to data, I can build a pretty beefy system in a couple of days, right? And then what happens is I start to run it, I get a couple of SMEs involved, and they don't like the answers. So then I get in this habit of talking to them and I get them fixed, and now I start to feel better about it. And then if you start to try to promote it to production, now you have a bigger breadth of data, and those responses, that more data is going to shift the responses on the back end. We can't continue to manually validate that. So automation is a big problem, right? You have to be able to automate it. So if I think about it, like, think about how we develop systems, right? if I go all the way through, and we see this all the time in almost every project I've seen, is that we do fine in the sprints, and then we get into integration and things are failing. And it's like nobody thought to test end to end, right? So then we talk about that and we start testing end to end. The difference is that validation with current applications is a yes or no, right? TDD, it either passes or fails. When we look at evaluations for our language models, it evolves, right? It's not a pass or fail. It's like, how well does it score? And so what's our scoring threshold? So those scoring thresholds need to be determined while we're building the product, right? That should be part of what product management's job is when they're defining these systems. It's defining what are the measures that we need to pass in order to keep this into production. And then those things need to run on a regular basis. So I've been in a couple of environments where when you talk about evaluation, in both cases, they decided to roll their own, right? Now, maybe in the long run, that's the right thing to do. But if you're going to do that, you need to be very systematic about it, and you need to know why you're doing it. And so I think part of the problem is maybe kind of a gap in understanding of what it really means to to have an evaluation in place. And again, I think it should be thought of more as a, correct and recover than a test, right? So we want to be thinking about that. And so basically that becomes your competitive moat, right? Is your evaluation telemetry. Can I do this? Can I measure? Can I explain my responses? Can I continuously improve the behavior without having to pull it back, right? If something fails in production or doesn't look good in production, I don't want to pull it back. I want to fix it on the fly. Right? So I don't need to go into this, but this basically is like the TDD philosophy, right? Design, build, evaluate, improve, right? So that's the cycle. But we need to treat it as first-class citizen. It needs to be part of the system design. And so then, we want to start thinking about past the performance metrics, right? We have collaboration metrics, scalability metrics, ethical coordination. The scalability metrics, that's where I think you need to be measuring the evaluations against latency and things like that. Right? Now, I'll go through these quickly. I know we're getting close on time, so we want to start looking at and while there are three areas here, I think scalability and ethical coordination, they're kind of clear in and of themselves. But when we talk about these collaboration metrics, we want to look at, when we're looking at agents, how efficiently are they coordinating, right? And so an example metric might be, if we have 3 milestones and we exchange 100 tokens, is that good or bad? And we have to start to measure that and trend it, right? Communication quality, the LLM rated clarity, right? So is it relevant to the inter-agent messages? So not only are the messages coming to the user relevant, right, in some sort of scoring range, but the messages going back and forth between the agents. Decision synchronization. So do the agents align with the actions and the decisions for the outcome, right? And so we can start to measure that with percent aligned against the outcome. Did we call an agent that we didn't need to? Group alignment, fair work division, right? Consensus on a plan. Pretty straightforward, and then score for bias or collusion. And then resource utilization, efficient memory, compute time, task prioritization. So this could just be computational load, user value that we score on the back end. And then the planning score. And then this is kind of typical benchmarks for your LLM plan. Right? So the questions you need to be asking yourself is, do you have real-time telemetry in your AI agent's decision-making process, right? Can you trace and explain every action that an agent takes in production, especially in production, right? How do we measure safety, trust, and ethical alignment? What happens when an agent behaves unexpectedly? Can we identify it? Can we correct it? Can we shut it down if we need to? Or our evaluation frameworks keeping pace with deployment velocity? right? Again, this goes back to the habit that we get ourselves in is we can think about something like testing. We've always got an excuse to push it to the end. This has to be built in from the beginning, or it's going to be a monumental failure. So if you can't answer these questions, you're flying blind.
Hey, Marty, if you could go back real quick. We had an interesting question from the crowd. Just given the state of affairs with LLMs and agents, are we really ready to have them in critical and high stakes use cases?
Some people aren't. You know, I think we've seen this even in our training, right? The interesting thing about LLM or GenAI development that I've found over the last couple of years is that it's not hard to do, right? It's not hard to create an LLM app or like a prototype or a project. You know, you watch a YouTube video, you can do some cool stuff. The problem is that if you're a junior developer, I'm trying to say this like I'm not trashing anybody, right? But if you've never built a production system that if it goes down, you're the one who gets a phone call, and maybe you're the one that is driving in their car looking for their next job after that phone call. Until you've been there, I think some of these things seem like it's somebody else's problem. But if you don't have these kind of things in place, yeah, I think it'd be a disaster if you deployed them in your organization. Now, I think there are design patterns and recovery patterns that we know and that we've learned. And if we take an architectural approach at how the evaluation fits in with the agents, then I think we can build some pretty good systems, right? But we can't just let them go do their thing, right? It's not like, you know, what I would be afraid to see is we know that OLTP works, right? We know that if we have 6 steps, something fails, we can roll it all the way back. Well, I could do the same thing with agents, right? I could say, hey, for every agent call, you know, hold a state, hold a state, hold a state, hold a state. And then I get to the end, I don't like the response. And I can go back and basically undo everything I did, right? I think that would end up being a disastrous kind of system, right? And so we have to be careful. But my short answer to that long response that I just gave is we can do it, but we can't go kind of seat of the pants, right? We need to understand what we're building, why we're building it, how the evaluations fit in, and what we're going to do. We have to prepare for when the system breaks, right? Because it's going to break. We break things all the time, right? And how do we take care of it?
Thanks.
Mm-hmm. So then this is my my slides because I'm colorblind, apparently, right? So basically, I think the future belongs to organizations that can prove not just what their AI can do, but that it's reliable, safe, and it can do it ethically, right? So that's my story, and I'm sticking to it. Pretty sure it's the last slide, yeah. So sorry, I went up tight. I'm glad we asked questions as we went. But if there are any other questions, I'm more than happy to hang in.
Great. There's no questions from the crowd at this point.
Cool. All right, guys, I appreciate your time, and have a great day.